as we can see. So that's really where I'm going to things. I also don't have my business, and I started out a business about 5 years ago, and I did very things, and then my sister, who's in Lisbon, had just left a decentralized derivatives protocol for Vega, which she co-founded. And she came to me and said, I want to start marketing for trading fund, which is a trader. And it's top of the boom a few years ago. We were trying to custody $50 million USDC, which was raised from investors, invested. And she's like, custody has been technical now. So I didn't know too much about Web3 back then, but yeah, I just learned it all, really try to work out the best custody solution. For various reasons, we couldn't find a custody solution suited us, which is where the sort came from. And at the time there as well, I was working for a VC, some diligence advising sort of things there. And I ran some validators, mainly tendermint ones, actually, not Ethereum ones. But yeah, some of my So yeah, today I'd just like to talk to you a little bit like just about the basics of custody. Some people will be very familiar with custody. I'm all in custody in terms of sharing the assets between groups of people. Not so much, having your own custody than that. So I'll go through the basics of custody and then I'll talk about distributed MPC. I'll show you how Salt is using distributed MPC, and I'll go through the space of it. And hopefully, it's no constant SC gaming guys and jumping in and stuff. All right, how do I change slides?
Yep.
Next one. All right, so basics of storing digital assets. It's two types of way digging up to the funds. In an externally owned account, or what that is just a private public key pair, or you can custody them in a smart account, structure, and smart accounts you can put like logic and rules around. Slide. All right, so a little bit of history of custody. In 2016, Gnosis Safe essentially started, I should say, and it was multisig Ethereum. Ways, and Gnosis Safe grew really quickly and product, but for custody of my groups, and trading organizations, problems. The first problem with Gnosis Safe is that it's not a chain, which means you have to launch. Oh, thanks. You have to launch a vault on every single chain that you want to custody funds on. So now if you have multiple signers across digital assets, across multiple chains, then if you remove a signer from a vault on one chain, you've got to remember to remove them from all chains. Then it gets more complex if you want to put risk management policies on it. For example, spend limits, whitelists. Now, not only have you got to do it on one of the vaults, you've got to remember to do it on all the vaults. So you can see that as you try and scale it up, Gnosis can become a bit clunky for that. And the other thing with Gnosis is they are developing out their policy layer to make it more sophisticated. However, the policies sit in smart contracts, so smart contracts are public. So a lot of trading houses, especially, do not want their policies as to when they will close out deals, who their counterparties are, and all that sort of stuff. They don't want them public. So Gnosis is still a great tool, but there was definitely a gap in the market for something else. So in 2019, Fireblocks, they're certainly not the only centralized custodian, but they're probably the biggest one, came to the market and they grew very quickly, essentially because they solved the problems that Gnosis has. So Fireblocks, all the policies are private off-chain, so they're not public, which is great. And yeah, the other good thing about Fireblocks is it's multi-chain. And it's multi-chain because, and I'll get it onto that in a minute, but essentially they can form a transaction and then just push it to the RPC node on any particular chain they want to. So So that's centralized custody. I'm going to talk a little bit about centralized custody because why am I bothering with decentralized custody if centralized custody is the answer? So I'm going to talk a little bit about that and then talk about dMPC. All right, so if you have a look at a CFO of a digital asset organization, they have a hierarchy of needs. That is, they want to keep the private key nice and secure. That's fine, but they can't just keep it to themselves because they're an organization. They have to have, other people using the digital assets, being able to sign transactions on the digital assets. They also have to earn a yield and a return on their digital assets. So just storing them all on a ledger under their pillow is great, but it actually doesn't sort of help a CFO too much. So what they've generally done is turn to centralized custodians to help them with that problem, and centralized custodians have solved some of the problems of Gnosis, so that worked really well. However, centralized custodians have some problems. The first problem with centralized custody is the trust assumption. So a centralized custodian will retain some or all of your key material, and it can be problematic if they go dark. So you think about Silvergate, FTX, those collapses, what happens when you've got digital assets with them, it's problematic. The other problem with centralized custodians is they're not free from government influence. They could be asked to, freeze your funds and things like that, which is also a problem. And then the last big problem with centralized custodians, they're actually quite expensive. So when we were looking to custody 50 million USDC for our investors, we then had to make a return on those assets. But one of our biggest costs was actually going to be paying Fireblocks or a similar custodian because they charge transaction fees for inflows and outflows from your wallets. So yeah, centralized custody is a step in the right direction, but it's certainly not the answer in my opinion. How decentralized platforms work? They work a whole bunch of different ways. This is just one way, and a lot of them reconfigure it how they like, but essentially you have a platform layer here, which is sort of very Web 2-like. You have the user devices coming in using API authentication, so they will propose the transaction they want to do. The platform will then check off the risk policies, such as whitelist, limits on transactions, that sort of thing. They may also then ask other devices to, okay the transaction if a CEO's got to sign for it or whatever it might be. Once it's all clear and it's passed all the risk checks, they will then run 3 MPC nodes generally, although it can be more, and they will push that transaction down to the MPC nodes, which then use a private network to communicate with each other and sign off their share of the transaction. What the nodes don't do is they don't share their share of the key with each other. So if you've hacked one node, you still have to go and hack the others to get all the private key. So that's essentially how centralized custodians work. All right. So is there another way but trusting your centralized custody provider? Well, what I'm here to tell you today is there is another way that can have the benefits of a centralized custody provider without the risks that you're running by using it. So it's called decentralized MPC or dMPC. It was originally came from an academic paper called Distributed Key Generation with Ethereum Smart Contracts by Philip Schindler and other authors in 2019. He actually has a GitHub repo that you can go have a look at. And it basically just proves the concept. And then in February 23, the project raised $2 million to create like a commercial audited SDK version of this technology. And that was backed by Coin Fund, MetaWeb, and Python, which is the trading company that my sister and I founded back then as well. All right. So how does dMPC work? Like, why is it going to be pretty handy? Well, dMPC allows you to create an organizational wallet up the top here, and that is basically an EOA. So if you go look at it on Etherscan, it will just look like an EOA. It will be indistinguishable from any other EOA. And it will have an address, and the control of that EOA is actually split amongst participants here. Now, I've just got an example of 3 participants. You can create ones with much more than 3. But like this guy's got his EOA in MetaMask, this guy's got his EOA in a ledger, and this guy's using a different hardware solution. And what happens is the first guy proposes they're either called DEOAs, organizational wallets, or vaults. Those terms are sort of used interchangeably. I don't like vaults because it sounds like Gnosis vault, and it's not. I'll call them organizational wallets or DEOAs. So the first guy will propose that a DEOA is created, and he will say, I want these other 2 guys to be signers on the DEOA. And then they are listening to events on the smart contract, because each DEOA has its own smart contract. And in front of that smart contract, there's actually a routing contract so that they know that there's a smart contract they need to start listening on. And they will start listening for events, and they will realize, oh yeah, you know, someone wants me to join this vault. And if they decide to join it, they will start the ceremony process to essentially create the private key. It uses decentralized key, distributed key generation. So this organizational wallet here has no seed phrase. These guys down here do have private keys in their EOAs, but here there's no seed phrase to, which is quite handy. And these guys here are just running a light little NPN node package. That's doing all the cryptography locally. There's no APIs or anything like that. There's no centralized server. They're all running it locally. They're listening for events on the smart contract, and that's how they're participating in the DEOA. All right, so what configurations have you got once you've set one of these things up? You can add or remove underlying signers, which is those EOAs I was showing in the previous slide. And that's super handy, because if you're an organization and you've got 5 people on a wallet and then someone leaves the org, well, you just drop them off that and you put someone new on. You don't have to change the top decentralized address. That stays the same. But what you've done is you've removed one former staff member and you've put someone new on. So you can rotate out easily, which is great. And then for security, you can also do a key refresh, where you essentially just issue everyone new key shards. And it's more just security. If someone's hacked one of the participants and they're listening under APC protocols, they can start to work out key information of other participants. And so you can just do like a key refresh to reduce the chance of that hack occurring. So each DEOA has thresholds, and a signing threshold, 2 or 3, 2 or 5, 3 or 5, 4 or 5. That's how many people are required to sign the transaction, have to agree with the transaction. Rotation is when you want to remove a participant, like I was talking about before, you have to get agreement on that. And you have to get a certain threshold to agree on it, which is really important. And if you set your rotation threshold really low, then even if you have 3 or 4 signers on a DEOA and you get a low rotation threshold, someone can just rotate everyone else off the wallet and steal the tops. So you want to set a sensible rotation threshold. And then the administration threshold is not particularly exciting. You can name your DEOA, things like that. All right, so how would a transaction flow actually work? If we think of 3 people, Alice, Bob, and John, Alice proposes a transaction to the smart contract, and Bob will listen, see the event, there's a proposed transaction, confirm it, and then either, and we're talking about a 3-person vault here, either now John or Alice can confirm it, because Alice can actually confirm her own transaction, which is takes a bit of time to wrap your head around, but Alice can do that, or John could do it. So once a transaction is proposed and confirmed, then any participant can take the transaction shards, I guess you'd say, which are in the smart contract, and combine them, and that happens locally, and that forms a fully formed Ethereum transaction, and then they can push that to the relevant EVM chain that they want to have the transaction on. All right, so this process is great because it's really, really decentralized. It's really secure, because if you hack one of the underlying signers, you don't have any information about the other underlying signers. It's there's just really no information. You might know what their ELA is if you look at the smart contract, but you don't have their IP address. If they're not privately networked, you know nothing about them, so it actually makes them hard to find. But where it is difficult to deal with is that it can be a bit slow because one person has to propose a transaction, and then it takes a block cycle for that to occur. And then as other people confirm the transaction, it takes more block cycles, and it also takes gas for each transaction as the underlying participant proposes and then confirms. So we're running it on Polygon because it's cheaper, and there's no reason not to, because you can then form the transaction and push it to Ethereum. So that's handy, but it's still a bit slow. And some trading firms like to do thousands of transactions very quickly, and even Polygon's going to be too slow for that. So what you can do is, instead of using the smart contract for all its functionality, you can just use a smart contract to keep the key shards of the ELAs and the configuration thresholds I was talking about before. So that is kind of handy, because if you lose these key shards, and these key shards are encrypted to the ELA. So yes, they're public in the smart contract, but the only thing that can decrypt the key shard is the ELA, the private key of the ELA that controls it. But yeah, if you lose that information, then you lose your vault. So you definitely don't want to, or your DELA. So you don't want to do that. But the transaction proposal confirmations, they're only really useful while the transaction is being formed, and after that, doesn't matter so much. The transaction's done. It's already submitted to the blockchain. So what you can do is you can take this out of the smart contract, and you can either put that in a database you run yourself, or you can use like a distributed database or any other sort of cache storage medium you like. And what that does is it reduces the gas requirement for proposing and confirming transactions, which makes it cheaper, and it also makes it way faster because you're not waiting on blockchain cycles. It's not as secure because for the participants to communicate with each other, they then need essentially a private network to communicate with each other. So it's not as secure, but it's still pretty secure. Just because you've got a private network doesn't mean you're vulnerable. You still have all your firewall and all your protections around that. So some of these features I have sort of touched on, but I'll just go through them. So it's cross EVM out the box, which is handy compared to account obstruction and smart accounts. It supports everything an ELA would. So you can transfer NFTs, ERC20 tokens. You can sign arbitrary messages for DeFi. So your distributed ELA can trade digital assets on DeFi platforms. So there really is no limit. There's no limitations on this as to what you would get in ELA. It's an open protocol. You don't have to have a sales call, a demo, sign up to something, and that's a bit scary. It's just open. You can just go on the web, download the SDK and start playing with it. It's very lightweight. It's implemented in both Node.js React environment, or you can just use pure JavaScript as well. There's two SDK flavors, depending on how you want to deploy it. It's very cost efficient, much cheaper than signing up to a centralized custodian signing service. I believe it's more secure than centralized MPC if you do run it fully decentralized, but you have those drawbacks. If you run it where you're using a sort of database for the transaction proposal and confirmation, then it's definitely as secure as a centralized custodian. And yes, I've gone through the low latency already. All right, so I'll go through two use cases. Salt's using it for custody, so I'll go through that one, and then I'll go through progressive onboarding, which is another great use case. So custody, right? So there's a screenshot of our DApp, which is pretty in all, but doesn't actually tell you how it works. And this is how we're using it. So essentially Salt, when it's released, is a web app, and CFOs, CEOs will log in to Salt. They will log in using an ELA. Their ELA, they'll create an organization, and then they can go create accounts. They can add users to accounts, and then they can add policies like blacklists, whitelists, all that sort of thing. And so that sort of sits up here. And then what happens is down here is where you have the DEOA technology, and Salt is basically an orchestration layer for the DEOA technology. So when you invite people to your organization, what that will do is allow them to log into Salt with their EOA and become those underlying participants on the DEOAs so that they can propose and confirm transactions. And what happens is when an organizational signatory is an underlying signer on a DEOA, if they go into Salt and they propose that they want to do a transaction, and then after that time, other organizational signatories can they'll get notifications and they can essentially confirm that they want to do this transaction or they don't want to do it. And also we have a concept of robo-signers, which it's basically like an automated signer. And what's important to understand about Salt compared to a centralized custodian is that all the key material and all this sits inside the project organization. So all Salt does is just provide an orchestration layer for it. The actual key material sits always with the organization. So the organization will set up a robo-signer, which is like an automated signer. It's just set up at the moment, using Amazon EC2, and we've just got CloudFormation to set up really easily. And it will store some key material. So it's kind of clever because we've set the threshold high enough that if one person here proposes a transaction, then the robo-signer will go and check that it meets all the risk policies that have been placed up here by the CEO and CFO. And if it does, then the robo-signer will agree to sign off on the transaction. And so now you have enough key material that transaction can be formed. So once that happens, the robo-signer will then form the transaction and submit it to the relevant blockchain. So yeah, that's sort of like our architectural map. And then if for some reason someone proposes a transaction that fails a risk policy, then Salt will take a bunch of different actions to let people know what's going on. So it's going to look and behave very much like a centralized custodian, but it's actually using decentralized under the hood. And if Salt goes dark or we go rogue or something, it's pretty simple. You've got all your key shards. You just go use the NPM package and go transfer your assets somewhere else. So we have no control over your assets. And if we're asked to freeze or lock your assets, we can't. We actually have control of it. We can shut off your access to Salt, but you can still use the underlying SDK to move your assets. All right. And use case 2, which is a very cool use case, I think. It's called progressive onboarding. Now, if you launch a DApp, and this has been looked at by a number of games actually at the moment, but essentially you launch a DApp, especially a DApp for where you can have groups of people from an organization wanting to use the DApp. You have a bit of a problem, and that is if you just go off and get like a wallet as a service product and custody their NFTs or whatever you're generating for them, tokens, well, how long do you have to do that for? What if they don't log in again? Like, how long's your custody period? So, and you've got to keep paying your wallet as a service provider, and that can be quite expensive. So that's sort of kind of a problem. But if the day one, when someone jumps on your DApp and they don't know too much about it, and then you're like, hey, here's some key material and seed phrases, and we need more backups and blah, they're just like, this DApp's too hard to use, don't use it. So you sort of have a bit of a problem as to how do you solve this problem when you're a DApp. And this technology solves it really well because it's called progressive onboarding. So day one, when someone logs into your DApp, you create a DEOA, and you as the DApp provider have two underlying signers to it, 2 of the key shards. And when they log in, you attach one to their MetaMask EOAs they logged in. So so you have, as a DApp provider, you have custody of the assets because you have 2 key shards, and you'd set a 2 of 3 signing scheme. You never set 3 of 3 because there's no point in having dMPC if you're going to go 3 of 3. You set 2 of 3, and they use the DApp. And then the thing is, the goal is after maybe 6 months, you don't want to be custodying their NFTs or whatever it is anymore. It's cost also, but it also could be regulatory, especially in the US. It's now getting harder and harder if you're custodying key material and custodying digital assets on behalf of other projects. There's more and more regulations coming your way around that. And if you're not, if it's like self-sovereignty and you're only providing services, then it's a much lighter touch regulation. So that's another reason why progressive onboarding is great. So what happens is after, say, 90 days, they log in and you actually force them to take over one of these. And how you do that is when you created your DELA, you set a fairly low rotation threshold, which means that you can just rotate one of your EOAs out and force them to provide another EOA and rotate it in. So after 90 days, they've been using it out. They'll probably quite like it. They'll probably go through that little bit of pain point, take a minute or two to do that. And then after 180 days, they probably really like your DApp now. They've got lots of assets in it. Everyone's using it. Great. Then you give them the last key shard and you force them to take it. So now after 6 months, you've progressively onboarded them and, they've got full sovereignty over their assets. And for everyone else who dropped off, and this is a big problem with game studios, a lot of players come in for a few days and then drop off. For everyone else who dropped off, you're not paying a really expensive wallet as a service provider for some unknown length of time to keep their account open, because this is an open protocol. If they log in 8 months' time, well, it doesn't really matter. You can just serve them up their assets. You haven't paid anything for it. So it works really well for that. And yeah, there's just some links. I will just in a sec. I'll just finish. Some links into the project that are developing the underlying wallet technology that I've been talking about. Their docs are great. You can reach their teams very easily off their website, and there are the SDK links. So, any questions?
Okay, can you go back to the previous one?
Sure.
So after the key rotation, is the address still the same?
Yes. Yeah.
Okay.
Yeah.
But
Yeah.
The previous MPC key owned by the platform.
Yeah.
Can it still be used to sign?
No.
Okay.
No. Yeah. So you literally rotate yours out. You force the user to supply another EOA, and you rotate them on it, and then your key is now essentially can't be used because you rotated it out. Yeah. Yeah. And that's sort of progressive onboarding. Yes. Yep.
Silly question, but why is this named in cross-check?
Why? Yeah, sure. Good, really good question. And one of the reasons we were super excited to use it actually. It's natively cross-chain because your underlying signers form the transaction and they only use the smart contract to like communicate with each other. But essentially they actually form the transaction on their own hardware. And so once they form the transaction, they can then push it to any RPC node they like. So they can push it to a Polygon node, an Ethereum node, etc. As long as it's a validly formed transaction for that network. And most EVM chains have very similar, if not identical, transaction payloads, then yeah, you can just push it to anyone you want. Yes.
Once I add this dMPC mechanism or solve to my application, does every transaction needs to be signed by multiple people in order to be executed, or can I also define maybe a certain hierarchy that I say like some smart contract functions or transactions can execute it automatically and everything else needs to be signed by multiple people?
Yes, really good question. Yeah, so at the moment, and initially for us, so the dMPC underlying protocol, you can take and configure that how you want to do whatever you want. But for Salt as a project looking for a custody solution, we're targeting treasury management at first. So essentially, one person can propose, and then if let's say they propose a small amount, and let's say their policies on the wallet say that only one person needs to approve that, then the robo-signer will go, oh, that's okay. This person's proposed it and that's all we need. So it will then just go and sign it and push it to the blockchain. And then if it's like a high delegation, then it will force more people to sign it. So yeah, that's essentially how it works with our implementation of it.
To make the question to this, like there are certainly some possibilities for exploits in this case, like maybe execute a lot of very small transactions. Like who has the responsibility to prevent those exploits? Does it lay with Salt or does it lay with the user?
With Salt and the robo signer, which is connecting into Salt. So you can set a policy that says you can only spend a certain amount of ETH over 24 hours.
Okay.
So if you're doing lots of little transactions, you're going to hit your daily limit, and then the robo signer will realize that it won't sign off on the transaction.
Okay.
Dan?
Maybe follow-up question. Where is the policies for the cost level?
That. So, yeah.
The Amazon.
This is Amazon EC2 container, which is in the project's own AWS instance, not ours. And then the Salt application is, yeah, just a hosted Node.js app, yeah, that we host. Yep.
The pre-original signers who have their chart, they rotate one of the other signers. What stops the pre-original signers from using the old chart for getting the transaction? Being able to validate the organization.
So you're saying if you have an organizational ELA and someone rotates someone else off it? Yep.
When you rotate one else, you get new cards. Those are the new sign, right? The two different cards no longer work, then you lost the second.
Yeah, that's correct. Yeah, it reconfigures itself. Yeah,
You
yeah,
reconfigure,
yeah.
but doesn't reconfigure. Where does it reconfigure? What layer? Because you have those existing free shards, and you can still form a transaction from the organization.
Okay. Yeah.
In the context of replication.
Yes, I'll just see if I can bring that up. Is my slide going? Right. Yeah, I see what you mean. So you're saying, yeah, the old key shards, how are they essentially like invalidated?
Yeah.
Is that what you mean? Are they invalidated? Yeah, that's a good question. I'll have to take that one on notice and ask the Intu guys and let you know on that one. Yeah. I know in the academic paper it does account for that. They do some paper cryptography, but I'm not a cryptographer, so I won't try and pretend I know how that one works. But I do know it does handle that situation on a cryptographic level. What's that?
Maybe there's a salt.
Yeah, it does it through cryptography somehow.
Are all the signers being the same? Like, is it using?
Yes. Yeah. And there's no technical limitation in using other signing schemes for other chains like Solana and Cosmos and stuff like that. Yeah. Okay. Any other questions? Right, thank you.
So we're just going to do
Guys, welcome to the Immutable Office. I know a bunch of you got here late for the apologies.